Hey guys, in today's video we're going to be talking about how to make an artificial intelligence aimbot for Halo Infinite. So recently I saw this video pop up on my recommended. If you haven't watched it, I really recommend it. It's really good by Basically Homeless. And you can see that a new type of cheat had come out using machine learning to detect enemies, so basically undetected by any anti-cheat. And you can see here a demo of how that works. And so you can see that's pretty insane, seeing as it's undetected. So I am going to be showing you how I made one for Halo Infinite, which I think is pretty cool. So first things first, I actually found online, I just searched up Halo enemy dataset, and I just found down here a dataset on RoboFlow, Spartan dataset, using these images. Just easily download it here, and I then trained that on Google Colab. So you can take a look at how to do that. I'll drop a link in the description to the video that helped me with that. And then now when you have your trained model, which you should have if you followed the tutorial that I dropped in the description, you can see here that this is what you should have. There's a GitHub in the description you can download all this from. And so I'll just show you how it all works really quickly. If we open this with Visual Studio Code, this is our main code. As you can see up the top, we just import a whole bunch of libraries, some inputs for the mouse, just some NumPy, just 132 AP, all of this stuff just for thing. We have some values up here, like if we want aimbot to be enabled, what we want the screenshot width and screenshot height to be, so that's the detection area in the middle of your screen where it's going to look for enemies. If we have headshot mode, we can like dial up sort of our aim so that it's aiming more towards the head. Now we have the window title of the video game, so you could theoretically train this for any game. And you can just change this value and change the model later on that I'll show you, and it'll work for any game. Except probably Valorant. They have a really good anti-cheat, and they managed to have stopped mouse inputs. But anyway, this is our movement amplification. This is sort of like how fast it will snap to the target. So at the moment I just got this set to 1, but you can go lower and it will go to the target slower, or higher and it will snap to the target faster. And now we're just initializing using our MSS library, screenshotting basically, is what this is. And we have some detect functions, but basically we'll scroll down to the very bottom for a start, and you can see this is where the main thing happens, is we run our main loop with our run loop equals true. And you can see up here there's another option to do it with a video output, so you can sort of see what it looks like what the AI is seeing. But anyway, if we go up to our main function, you can see we have it here. So first things we do is we just print out some stuff, then we load our model, and you can see that if you in the thing we have our model right here, our weights file that we've trained. So you can just change this weights file name to whatever model you've trained, whatever model you want, just change that there, and you should be able to use it there. Then we just take the classes. So basically, if you look at what we were at before with our model, you should have maybe seen on the website that it had 4 classes. It had our enemy head, our friendly, and our friendly head. And so just for this video, we're just going to be working with just enemy at the moment detection, but it can also detect friendly head, etc., etc. So now if we want to run the loop, which we'll pass in as true usually, I don't know why you wouldn't. I don't know why it's there. Really, just if we want to run the loop, if we want to do it, yes. Then what we want to do is want to try and get the window. So this is Halo Infinite. So if Halo Infinite's open, we're going to try and get it. And otherwise, we're just going to quit out because it failed. The window wasn't open. And if, seeing as we did get it, and it went through here, we're going to activate the window. And we're going to set our screenshot area using our screenshot height and width. So just setting that up there should set it for you. Now we're going to check if we're video outputting. We want to set our all these values and create a OpenCV video writer. as out. So just with our FPS, our width, our height, etc. I've just set mine to 20. I think just figure out what sort of speed your AI runs at. Uh, there's a debug log later on that'll do that for you, and you can change that value according. But that's basically just the output of the video, so the output video will be at 20 FPS. Then we just start with saying this is frame number 1. We say that we've run through 0 counts. So we set the variable count to 0. And here you can just uncomment these 2 lines here if you want to see a real-time extra window pop up of what the AI is seeing. But anyway, so in this we're starting up a loop, and in the loop we're gonna grab the area, a screenshot of the area of the screen, and we're gonna put it, and we're gonna make it into a numpy array. Then we're gonna set the variable frame to image, and we're going to set frame to this color because we want to set it to this color so that our aimbot will use the correct colors to detect it well. We want to set our results to the detect function up here. So in the detect function up here, you can see that we're simply taking our frame and we're turning it into the array frame, and we're feeding that into our model, which we initialized earlier. Now if we go back down, after we do that, you can see that we go frame equals plot boxes. The results, we feed in the results of our detection. We feed in our frame, we feed in our screenshot area, and we feed in our classes. And now if we go up to here, this is where most of the aiming actually happens. So inside plot boxes, we take in these. It takes results, frames, and classes, and it contains labels, and the results contains the labels and the coordinates, and the classes contains the string labels. Now our labels and coords equals results, so we're splitting it up, and then our number is our number of labels, and our X shape and Y shape is the shape of our image, sort of, the frame.shape, yeah. And then we have a highest confidence detection, so this is the enemy we're going to want to aim to. So first we just set it to none up here, and we set our closest mouse distance to infinity. And then we set C width and C height to the area, to the width and the height divided by 2. And this doesn't matter, that doesn't need to be there. And then for this is just a for loop. For every label that we get, for every detection that we get, we're going to set our row as our coordinates of whichever detection is coordinates, and then we check if 4, which is the confidence value, is bigger than 0.65. Then we want to work with it. Otherwise, if it's less than 0.65, it might be just invalid. It's probably not right, so we're just going to discard it. Then we check, first we set our center X to a little bit of math, and basically that's the center of the bounding box, center X of the bounding box, center Y of the bounding box that it draws around the enemy. The center is the center, and then of course we take away the width and the height, and then we get the real center. And then we set our current mouse position. We get this using win32api.getCursorPos, so that returns our current mouse position on the screen, and we do a distance function to find the distance from our current mouse pod to our center X and center Y coordinates. And then we check if our distance is smaller than our current closest mouse distance, and it's an enemy, or it's smaller than thing and it's an enemy head. I think that is. Oh no, sorry, that's using a different. Thing. If you label your thing as 0, just that's not really important. Just this line right here is important. And use and then we set the highest confidence detection equals this coordinates, because that is the closest one to our mouse, and we set our closest mouse to the distance. So then when it loops over again, it goes through all of them. And it figures out which one has the closest mouse distance. And down here we draw a rectangle using our bounding things. So that's what you'll see on the video output if you save a video. So now we check if we do have a highest confidence detection, so if we actually detected anything, then we want to set our coordinates to our highest confidence detection, and get our box height, which is our y1 minus y2. Then we need to check if headshot mode. If we're using headshot mode, then we make headshot offset our box height times 0.35. Otherwise, it's just our box height times 0.2. Then we do our math, and we get our center values again, but we add headshot offset to the center Y. And now, if we're using our aimbot, we move our mouse using Win32 API mouse event to we pass these into an integer so that because that's what this takes as input, and it's just our center X and center Y times the movement amplification. So that's basically the sensitivity, like I said before. And then we return frame for if we want to do any video output. And then we come back here and we can see that we have made it to here in our code. We've just passed there. And so now we check if we have a video out, then we're going to out.write. So we're going to write through the video thing out to the frame. And it is going to, well, write that out so that when we end this program, we're going to have a finished video ready to see. Now we're going to check if we get the key escape, basically. Well, we have to do cv2.wait key so that this will keep passing and this will keep passing and all of this. But also, if that happens, and we press escape, then we want to break out of this while loop and stop the aimbot essentially. And actually no, sorry. This is just to check. This is just to make it work. I don't know why that's there really. It just has to make this and this stuff work and everything. I don't fully understand that. Now if we get the escape key pressed, however, then we debug out that we're exiting, and if our video out, then we release the video writer and break out. And if we break out, it's just going to print that it's cleaning up, and then it's going to exit. But if we stay in the loop, so if we don't press escape at all, it's going to add to our frame number, and it's going to add to our count, and then it's going to check every second. It's going to do some garbage collection just to speed up a little bit, and it's also going to print out our counts per second, or our FPS basically, that our detection is running at. And then it's going to reset the count. So what we want is basically the higher this value is, the better your result's going to be. So now for the demonstration, and the setup sort of. So basically what you're going to want to do is you're going to want to have Anaconda. So you can get that at anaconda.com/products pretty much. Yeah, /distribution, and there's just should be a Windows installer right here. You can just download that, and then you should be able to, and you should end up with this Anaconda prompt here. Now you can see that we're just here, but we actually, for Halo, we're gonna have to run this as administrator because Halo's anti-cheat actually does stop input from Python programs. However, it is not actually that great because it is only running in user mode. So if we run in administrative mode, it simply just bypasses it and allows us to do it because we have more permissions than their anti-cheat, which is not great, and they should probably look into that. But anyway, basically what we want to do is we want to cd to our repository, and now that we're in it, you're gonna have, if you look in the repository, there is a readme to help you set up all this and what you need to install and everything. But basically, when you've done that, what you want to do is you want to run conda activate PyTorch GPU, which is a virtual environment that you will be able to create if you look at the readme on the GitHub in the description. Now, we come into this virtual environment, and now I can run Python scripts on my GPU, so they will run a lot faster. And now if I open up my Halo Infinite, okay, there we go. Alright, we can now start our program again. And if we do this, it should put us into the game. Boom, and you can see it's tracking our enemies. I'm not touching the mouse right now. And if I click, you can see I hit them. And if I zoom in, you can see it's tracking them. Now, this can be obviously improved with a better GPU, but if I come like here, for example, you can see it lock on. Huh? But yeah, as you can see, it works pretty well for now, with the occasional miss or two, of course, because it is not perfect. But it has a pretty good rate of success. This is a good one, is when they go like that, because you can see it lock, like that. So it's pretty good. Works pretty well. You can see it's getting some false detections on the trees. That doesn't really usually happen. It's just the firing range is kind of a bad place for it, because for some reason the grass in here really trips it out. But yeah, that is an ML Python aimbot. And I trained this on only 669 images, so it can do a lot better with more data. One thing that you do have to do is you do have to set your enemy outline colors to pineapple, because that is what they were trained on, so that is how they will perform, is only with Python, is only with pineapple as the player color. So you can see though, when I like scope in, it's not detecting really that much. That's because it's just detecting this small middle area of my screen, and it's hard for it to distinguish a whole enemy. But when I zoom out, it gets good detection. So you're still gonna not, it's not gonna lock them perfectly if it is like moving around like this or whatever. But it will lock pretty well if you scope from far away, and it will lock pretty well if you just don't scope from close. Also, you can see it doesn't hit every single shot. That's because it has some slight lag. So you can see that if I go to my thing, I'm only getting 27, 35 sort of 30 FPS detection rates, and that's not amazing. That means that it's only going to be able to move at 30 FPS, the mouse. Of course, I'm using a sort of oldish GPU, and it's not that great for it, and also my code's probably not fully optimized as it could be. So you can definitely get better results than this. I also had to cap my game at like 40 FPS, because that was the only way it could get better results. But yeah, that's the aimbot. Source code's in the description. You can have a look if you would like.